All right, lesson 10.2, tangents to circles. Tangent is the name of a line. You guys don't need your homebooks out. All right, so what is it that we're doing today? We are identifying parts of a circle. So the only thing that we've talked about so far is a radius and a diameter. So we're going to learn a lot more today. Identify parts of a circle. That's our goal for the day. Now, I'm going to define all of these parts. So I'll make a big circle. All right, a chord. I brought up this word yesterday. A chord is a segment that has two endpoints on the circle. So that's a chord. So it starts and it stops. Okay? A secant is a line that intersects the circle. So I'll just draw it like this. It has arrows on both ends, so it goes in both directions forever and ever. Secant. A tangent line. It's a line that touches in one spot. And I will, so it's going to hit like one point. Tangent. It's a line. Tangent line. Okay. And then tangent circles. Circles that intersect in one spot. Concentric circles. They're embedded in each other. Circle within a circle. So I could have like 3, 1, 2, 3, things like that. 4, 5, 6, you know. A point of tangency. Okay, this is the point at which a tangent line, this right here is the point of tangency. Right there, where does the line hit the circle? That's the point of tangency. So I'm going to leave this shape up. I can get away with doing it for like a few examples. So I'll leave that image up. And yeah, this is fine. Tell what each thing is. Okay, here's the diagram. Segment AD. What's AD? Yeah.
A chord?
No, something better. Because it does hit in two spots, but there's something that's actually like a better definition of it. Yeah.
A diameter?
A diameter. That's a better definition. Great. What's CD? Segment CD. It's a radius. Perfect. All right, people on Zoom, it's all you. EG, it's a segment EG. EG. What is it?
Tangent.
Tangent. HB has a segment symbol above it. Because then E is HB with a line above it. They're different. HB and HB. Okay, tell me. D. This one versus this one, which is which? Look at the vocab words up above. HB. and HB line? Hold on. Anyone, Zoom people.
Is it a chord?
This first one is a chord because it starts and it stops. This second one is what? My last vocab word. The line HB, what is it?
Second.
Yeah, secant is the way to just pronounce it. Secant. Good. Okay. I mean, you were working with me as I went, so I can move along. Okay. If a theorem, if this first theorem, if a line is tangent to a circle, then it is perpendicular. That's this right here. This line L is perpendicular to the radius. So the radius, when you draw a line to the tangent, point of tangency, it creates a right angle, perpendicular. The converse is, if I have a perpendicular set of lines, and one of them is the radius, then the other must be the tangent line. So, opposite definitions, and that is what a converse means. Okay, let's do some. Is KJ tangent to circle P? Remember, it's tangent if it makes a right angle. So KJ, is it tangent? Does it make a right angle? I want to know yes or no. This 10 is the whole thing. So what would I do to figure out if the radius is tangent to KJ? People on Zoom, I'm going to need you a lot today. What method? I want this to be a right angle. I want them to be perpendicular. How do I figure it out? Hold on. Oh yeah, you're going to need them today. You'll need calculators today. Someone on Zoom. What do I do? You can't just sit and be quiet. Half of you never volunteer. Let's start thinking about it. Stay with me. How do I know if KJ is perpendicular? What do I do to figure this out? I've got a 5 and a 14, I got a 10. Class, hi, hello. Help me out here.
Wait, so you're trying to find out if what is perpendicular to what? Oh,
if the radius is perpendicular to KJ.
Oh, see if it's a Pythagorean triple.
Yeah, see if it's Pythagorean theorem. Like if I do Pythagorean theorem, so obviously my hypotenuse is 10. So a squared plus b squared equals c squared. Obviously, don't forget. Okay, my hypotenuse is 10. Isn't the hypotenuse supposed to be the longest side? So why would it be shorter than 14? Is this going to work?
No.
No. So based on what you've learned about Pythagorean theorem, the hypotenuse is the longest side. I'm not even going to do the math because it's a waste of my time because I use my prior knowledge to connect the fact, hey, the 14 and the 10 are definitely not going to work out to be, make this true. So it's just a quick no. Okay, look at number 4. Now, KJ is here. Is it tangent to circle P? So here's basically my triangle. 10 is what? It's right here, but what is that called? What's the vocab word for what 10 is?
A diameter?
It's not the diameter because it's just in this section right here. What else
Oh.
can I call?
The radius?
So 10 is the radius, which means that the diameter is how big? Someone else.
20.
20, yay. Here's my triangle. This is gonna be the right angle. It has to be this angle. I got a 20, I got a 21, I got a 29. Okay? So set up the Pythagorean theorem, guys, go. You need a calculator. And check it, see if it works. Is this a yes or a no?
Yes.
Yes.
Yes, because this 400 plus 441 equals the 841, that is 29 squared. So yes, it is tangent. Very good. That's a Pythagorean triple. Excellent. So now on the back side, we have a lot more Pythagorean theorem work, and let's go. So segment ST is tangent to R. Great, that means that there's a right angle right here. What is the radius of R? How do I solve this? Every side is labeled with something, right? X 24. What's the hypotenuse? How long is this hypotenuse? Say it. Talk, people. Turn off your mics and start talking. Okay, I'm just gonna call on people at random. David Kim. RT, how long is RT?
18.
So 18 is here, but then why would they put that X? So what?
It's the radius, or is it?
Okay.
Yeah, the radius.
So the radius is X, and then this is 18. So what's the full length?
Oh, are you still asking?
I'm still asking, it's your question.
Uh,
The full length.
18 plus x.
Yes, I'm gonna write X plus 18 just because that's the order it's in, but you're right, you put them together, you add them together. Good. Now that means that if I wanna know the radius X, I've gotta solve for X. And the only way that I know how right now is to still do the Pythagorean theorem. X squared plus 24x, or 24 squared equals, it's a binomial, X plus 18 squared. This is a binomial that I need to factor, X plus 18, X plus 18, right? 24 squared is 576. And then I have to factor it, FOIL. First, outside, inside, last. Do you remember all this? X times X. Outside, x times 18. Inside, 18 times x. Last, 18 times 18. 324. So now it's a matter of us combining like terms, getting isolating x. There's my. Actually, the x squareds cancel, which I love. So 576 equals, ooh, like terms, 18x and 18x. Put those together, right? 36x plus 324. Solve for x, go. What'd you guys get?
I got x equals 7.
You are right. That is true. X does equal 7, which is the radius of our circle. Very good. Very good. Right. So I actually have to do number 5 as like I have to scroll up. Greg, McKenna, Philip, Emily, turn on your camera. All right. So YZ and XZ are tangent. That means they connect to point Z, right? So what is the relationship between the two lines? What do I know about these two lines? Obviously, these two are the radiuses. They're congruent. Easy. Right angles are formed right here. Dun, dun. What do we know about these two lines here, these two black lines? Someone give me some thoughts. Go ahead.
They're both congruent.
They're congruent. They're the same size. Look at them too. They're congruent. They're the same size. So I'll draw my lines of congruency. Now, so if two segments from the same exterior point, Z, are tangent to a circle, then they are congruent, equal, the same. Here we go. If Tx is 12. Okay. Tz equals 20. Oh, I have to draw Tz. What are xz and yz? So here's 12. How am I going to figure this out? Let's just focus on one of the triangles right now. Like this top one. I have this triangle. 12 is here. It's one of my legs. My hypotenuse is 20. I want to know that tangent line, the length of the tangent line. What ought I do? What ought I do?
Would you use Pythagorean theorem?
Yes, sir. Here we go. 12 squared plus I don't know squared equals 20 squared. Go ahead and solve it on your own because you're so good at Pythagorean theorem now. So good. Okay, what'd you get?
16.
Very good. 16, because the square root of 256 is 16. Okay, part B. If the measure of x, t, y, okay, now I need to not care about the 12s and the 20 anymore. Okay. XTY is 100 degrees. What is the measure of angle Z? Well, look what I've got. This is a four-sided shape. My radius are congruent. My two tangent lines are congruent. Does anybody remember the name of this quadrilateral that I just drew?
Is it a kite?
It's a kite. So the degrees, all of the angles in a kite add up to how much?
360.
360. So, good. And I got a 90 degree, I got a 90 degree, I got a 100 degree, and I got a, I don't know. 90 plus 90 plus 100 plus what? Equals 360. What is it? What's the missing angle? Angle Z.
80.
80. Measure of angle Z, sorry, I'm blocking it, is 80 degrees. Okay. All right, all right. Almost there, and time is a ticking, so let's go. 6 and 7. All right, there's a bunch of tangent lines on number 6. So these tangent lines that I did on number 6 have some measures. I have 2 here. So what is this one right here? This is 2. What's that? These are easy, guys. Everybody with me? Hi. If you've already volunteered today, no volunteering. I'd love to hear some more female voices too, by the way. There's about, 18 of you in the class, 20, so. Tangent lines. If this segment is 2, what's this segment? This tangent line is 2. What's this tangent line that's connected to it?
2.
2. Easy, guys. Let's go to the clockwise around the circle. This tangent line is 3. What's this tangent line?
3.
Yeah, ladies, love it. This tangent line is 6. What's this tangent line?
6.
Yay, all the girls are amazing. Okay, this tangent line is 7. What's this tangent line?
7.
Awesome. Add up the perimeter. What's the perimeter of this quadrilateral? A, B, C, D. Two, 2, 7, 7, 6, 6, 3, 3. 36. Good job. Add them up. All right, last example. Number 7, not number 5, whatever. Assume that the line segments are tangent. this line and this line are tangent. They are equal to each other. So go ahead, solve for that. They're equal to each other. And what's my answer?
3.
Right. And you know what I could do? Plus or minus 3. This could be -3 squared. Could do that. Yep, they're both 11 long, but the value of x could be positive or -3.
Miss Graham, why do you add the positive or negative?
Because in this instance, it says x squared plus 2. So the x squared plus 2